And what Chapter 10 is going to be covering is circles. So all of Chapter 10 is going to be focused on circles and parts of circles. Now, whenever we talk about a circle, there's two ways that we can name it. One of them is going to be just saying circle P. So this here, because the center of the circle is point P, we're going to call it circle P. Now, another way we can do it is circle dot, pretty much drawing a circle with a center and then putting the letter P. So either one of these two here is a way that we can name a circle. Now, a circle is the set of all points in a plane that are equal distance from the center, which is the radius, because the distance from the center of the circle to a point on the circle is called the radius. Now, we do have some different parts of a circle. One of them is radius. We know what the radius is. It's the distance from the center of the circle to a point on the circle. Now, a chord is a segment whose endpoints are on the circle. It doesn't matter where they're located. As long as the two endpoints are on the circle, it is considered a chord. Now, we have a specific type of chord, which is called the diameter. And the diameter is a chord, a line connecting two points on the circle, but it goes through the center of the circle. So that's our radius, chord, and diameter. Now, a secant is a line that intersects the circle at 2 points. So essentially, it's a line that goes through the circle. Any line that goes through the circle or intersects the circle at 2 points is called the secant line. Or we can call it a secant ray or a secant line segment. The main point is that if it is secant, it intersects the circle twice. Now, the last kind of term we have on this here is a tangent line. A line is considered to be tangent to the circle if it intersects the circle at exactly 1 point. There is one spot that intersects, and we call it the point of tangency. So any line that intersects the circle at 1 point is called the tangent line, and its point of intersection is the point of tangency. So the first thing we're going to do here is look at some of these segments and lines and give them their name and call them what they are. So we're going to tell whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent of circle C. So when we look at this here, so the first one it's asking about is a C. So what is the best name we can give line segment AC? It is the, so where does it start? It starts at the center. 1 point is at the center of the circle, and 1 point is on the circle. So if it's going from the center of the circle to a point on the circle, exactly, it would be the radius. AC would be the radius, because the radius is a line segment that connects the center of the circle to a point on the circle. Any questions about AC? AB. Line segment AB would be the what? It would be the diameter. Because AB connects 2 points on the circle and goes through the center, it is considered to be the diameter. It is the largest chord we can draw in a circle. Any questions on the first two we've done so far? Okay, let's look at ray, DE. It would be tangent because it intersects the circle at how many points? 1. So this would be tangent. Where would the point of tangency be at for this ray? It would not be point D, it would be point B. Because the point of tangency is the point at which the line, ray, or segment intersects the circle. So it would be at point B. The point of tangency is at point B. And last but not least, we have line AE. It would be secant because it crosses the circle, intersects the circle at A and G. So this here would be secant because it intersects the circle at 2 points. And that's all we have to do for these here. Questions on any of these so far? All right. In example 1, what would best describe AG? So are we talking about a line or a segment? It would be a segment because AG, the line above it, does it have arrows? No, so it's saying it's not a line, because if AG was a line, we would have a line essentially drawn above it. So it's saying that AG is a segment, yes? A segment has 2, what? Endpoints, because a segment has a definite start, a definite end. And it's saying it's starting at A and going to G, yes? So is it going through the circle? No, it's connecting A to G, yes? If it was a line, then it would go through it, but it's only starting at A, which is on the circle, and it's finishing at G, which is also on the circle, yes? So AG would be a chord. If we had drawn a line above AG, then it would have been a secant. But because we're talking about the line segment AG, only this part right here, it is a chord because it starts and ends on the circle. It connects 2 points on the circle. And that's the key difference. Now, what would CB be? In example 1 for this here, name a tangent. DE. What would I put above it? I mean, we could put a line. I could put a ray. Could I put a line segment? Because does DE, a line segment DE, intersect the circle at one point? Yes. A little off. But that line segment there would still intersect at point B, yes? So I could call it a ray, I could call it a line segment, I can call it whatever I want for DE. But I mean, we could have also said DB, because that works, BE, BD, ED, EB. We can use any type of line that uses those 3 points to name a tangent. What would a secant be? Or tangent? Oh yeah, no, we actually answered both. As we said, we could say DE would be a segment that would work also. Or ED, or any of those combinations. Any questions on any of this so far? So far, we're mainly just using the vocab, the terminology for these here. Now, there is something specific with tangent lines. A tangent line to a circle intersects the circle, or kind of the radius, at a 90 degree. A line is tangent to a circle if and only if the line is perpendicular to the radius of the circle. Perpendicular to the radius of the circle at its endpoint. So the tangent line and the radius will form a right angle. If it is a tangent line, it will form a right angle. It'll intersect and make a right angle with the radius. So, looking at this here, if I want to determine, given this setup here, if ST is tangent to the circle P, if it is tangent, that there should be a right angle, yes? So, by doing this, we have set up a right triangle, because if this is tangent, that should make a right triangle for how this is set up. And if it is a right triangle, then a squared plus b squared should equal c squared. Then we can use the Pythagorean theorem, if this is true. So what would the hypotenuse for this triangle be? And our two other sides would be 12 and 35. Now, if 12 squared plus 35 equals 37 squared, then this is a right triangle. I have a feeling this is going to be 1,369. So at this point here, we just really need to use the Pythagorean theorem to determine if this is a tangent line, if these two are tangent to each other. Any questions on any of this here so far? Okay. Let's go on and look at the next one, because again, we'll do more than one of these here. Okay. So we have another triangle here. Now, in this class, unlike the ACT, because you'll have to take the ACT again, you've already taken it once. As sophomores, you'll take it twice next year. ACT will have almost, or a lot of the pictures on it drawn to scale. Big Ideas Math and the tests are not going to draw these to scale. I'm going to try as best I can, but they're not going to be exactly to scale. So we can't necessarily use the picture to say, okay, it is or it isn't. That's why we have to use the Pythagorean theorem. A squared plus b squared equals, so what would a and b be for this here? 24 and 44, because we want angle T to be where the right angle is, which makes 51 the hypotenuse. What else do we know about the hypotenuse? The hypotenuse is always the longest side. It's always going to be the biggest side. Now, 22 squared plus 44 squared is, are these the same? Is this tangent? Is ST tangent? No. No. Bless you. Or coffee. Any questions on this here? Now, because it did not satisfy the Pythagorean theorem, it means that these three sides of the triangle will not form a right triangle. And because it is not a right triangle, where T would be the right angle, it means that this line cannot be tangent. Because for this line to be tangent, it has to make a right angle with the radius. It has to make a right angle with the radius. Questions on this here? So what are our three side lengths for this one here? Right, so we want this here to be the right angle, yes? So 3 and 4 would be our two sides. So 3 squared plus 4 squared. Well, the hypotenuse should be bigger than our other two sides, yes? So the side length's not technically 2. What is 2? Point E. So the distance from the circle to point E is 2. What is the distance from point C to the circle? Well, what is that line segment? C Any point from the center of the circle to a point on the circle is the what? Radius, yes? And the radius will always have the same value no matter where it is on the circle. That's why circles are nice, yes? So what would that distance be? Because the distance, or the line CD, is the radius, yes? And we know it is 3. So any radius should be 3, which means CE is 5. Mm-hmm. 3, 4, 5 is one of the Pythagorean triples. As long as 3 and 4 are the legs and 5 is the hypotenuse, this will always be a right triangle. 3, 4, 5 is one of our special Pythagorean triplets. Any questions on any of this here? All right, we're going to come back to example 4 in a little bit. I want to make sure we get to everything else first. Now, external tangent congruency theorem. This is the next theorem we're going to look at. We'll come back to example 4 later. Tangent segments form a common external endpoint are congruent. So if we have two tangent lines, or two tangent segments, both of these here, RS and TS, are tangents. So they intersect the circle at one point. And they meet at a point outside the circle. So what this means for us is that these two segments are going to be congruent. Because the only way for these to work out is if they are equal to each other. So our external tangent congruency theorem states if two tangent segments form a common exterior point, they intersect at a common point, the distance from that point of intersection to the circle will be congruent. So if we look at this here, RS is tangent to circle C at S, and RT is tangent to circle C at T. Find the value of X. As we just said, those two segments are what? Congruent. They're going to be the same. Because we know that RS is equal to RT. So we can set them equal to each other. 3x plus 4 equals 28. And at this point here, we need to find the value of X. We would want to do it the other direction. We want to subtract first, because if we divided first, it still works. Because it would be X plus 4/3 is equal to, well, 28/3, because 28 is not divisible by 3. Then we would have to subtract 4/3 from it, which would be 24/3. And at this point here, we would divide by 3. 24/3. 24/3, so X is equal to 8. And this here, that division where we have to, if we divided by 3 first, we would have had to divide the 4 by 3 also. We have to divide everything by it, especially with addition and subtraction. Now, if it's multiplication, if it had been everything multiplied together, then we can do that, because division works with multiplication that way. We can split it up if we do it in the correct order. So whenever we're solving these here, we always want to use addition, subtraction first, multiplication, division second, and going there. And the way that I think the best way to picture it is almost like moving a house. The first thing you move whenever you're trying to move from one place to another is you don't move the washer and dryer first. If I'm packing, I'm not packing up and moving the washer and dryer first. If you're packing, the first thing you pack are the knickknacks, the little items, the small things. Try to move all of it first and then move the big items, the refrigerator, the washer, dryer, the beds. They always go last. Big things go last because they're harder to move. So addition, subtraction, I consider it like if we're moving the little things. Multiplication, division are our bigger items. And you'll eventually get to it in Algebra 2, but we talk about powers and radicals as the biggest things entirely. So we move them last. Unless it's unavoidable, then we have to move them. So value of x is 8. Any questions on this here? Okay. Point M and N are points of tangency. Find the value of x. Well, x squared is equal to 9. These two lengths are congruent. So to get x, to simplify x squared, we would square root both sides. And the square root of x squared is equal to plus or minus 3. Is negative 3 times negative 3 is what? 9. 3 times 3 is? So whenever we square root both sides, it's really that we have x is equal to plus or minus 3, because it could be positive or it could be negative values. So it could be positive or it could be negative. Now when we look at this here, if I plug it in to find the distance, it's talking about x squared, yes? So could this be negative 3? Because if I plug it in for x, we just said negative 3 squared is 9, yes? Does it work for this here? Yes. So it could be positive or negative 3. Because on these here with the positive or negative, we need to look back at the situation and make sure it still works for the given problem. And here it does. Even though we're talking about distance, the value of x is squared, which would give us our positive negative. Now if this had an x, or just a value of x somewhere else, then we have to look and plug in and make sure it works. Any questions on this here before we move on to what's next? This is not on your note sheet, I know that already. But there is a part of the assignment that goes along with this. In a plane, two circles, so we can have two circles, can intersect in 2 points, 1 point, or no points, where they overlap each other. Now, if we have, 2 points, 1 point, no point, they're concentric. What we can do is we can actually draw tangent lines between the two. Depending on how they're set up is the number that we can have. And what that means is that I can draw a line, kind of like this here. Let's do better. Make it a straight line. Exactly like this here, that intersects both circles in 1 point. So this line is considered to be tangent to both circles. Well, we can also draw, I can also draw one here. It's a little bit off, but we're able to draw two tangent lines that are tangent to both circles. Yes? So, for this here, for if they intersect at 2 points and kind of they're inside of each other, we can draw two tangent lines. Now, more specifically, they're going to be considered externally tangent. Because we have two specifications. We have externally tangent and internally tangent. Now, the reason I consider these to be externally tangent is because if we took the two centers of the circle and connected them, they do not cross it. If we drew a line between the two centers of the circle, and the tangent lines, tangent to both circles, cross it, then they are internally tangent. If they don't, they are considered externally tangent. So we can look at these here, and this makes it a little bit easier to see. So in this first one here, A, we have two circles, but do they intersect at all? No. And because they don't intersect, the two lines in red are tangent to the circles, but they do cross the line between the centers, yes? So these two tangents would be considered internally tangent because they cross the line created between the two centers of the circle. The two ones in blue are considered externally tangent because they do not cross that center, that line connecting the two centers. So they have four tangents, four common tangents, two that we can create on the outside, two that we can create on the inside. Now, if their point of intersection is at one point on the circle for each, where they intersect once, we're going to have three common tangents. One is going to be internal, the one that just goes straight down where they meet, and we have two that are external. And as we can see here, we have two common tangents, because here they overlap, yes? Would the blue lines be considered external or internal? External, because they do not cross that line that connects the two centers. Because if it does not cross the line that connects the two centers of the circle, it is considered to be external. Here we go. Let me add one. They share a common center. How many tangents would this one have? None, because a tangent can only intersect the circle at how many points? One. For this center one here, I can create any tangent, but as soon as I do for this smaller circle, it's going to become a secant for the bigger. So if they are concentric circles, they will not have any common tangents because there's no way to draw it. So part of the circles do have to be outside of each other. There will be questions on that on the homework, asking for how many, internally or externally. So really, if they are outside of each other, we can have four. If they're touching one spot, they can have three. And if they're overlapping, they can have two. But if they're inside of each other, they can have zero. Now, before we start this here, the last one we're going to do today, are there any questions on anything else that we've done so far? Now, this one here looks like it might be impossible to find because we have two different variables, yes? But it did tell us a few things. In this diagram, point B is a point of tangency. Find the radius of circle C. So they told us that AB is tangent to the circle, yes? Which means at B, angle B, what is our measure? This here would be a 90. Because if it is a tangent line, it forms a right angle with the radius. The radius and the tangent line are perpendicular. They form a right angle. Well, if that's the case, do I have a right triangle? Well, yes, because I do have a right angle and three sides. So that means a squared plus b squared would equal c squared. What are our side lengths of A and B? R squared and not 50. Because the two sides, A and B, are always the ones that make the right angle. Because R and 80 would be our A and B, so we'd have R squared plus 80 squared. The hypotenuse C is always opposite the right angle. R is not going to be our hypotenuse, and 50 is not the hypotenuse. But what is? Almost. Because we wouldn't multiply them, we would add them. So we'd have r plus 50 would be this entire length, and we would have to square it. So we can find it using the Pythagorean theorem to find this here. What is r squared? R squared, because we don't know what r is, it's just still times itself. But we can figure out what 80 squared is. 6,400. What is r plus 50 squared? Well, r plus 50 squared is the same as saying r plus 50 times what? Because whenever we square something, we're multiplying it by its self. Now, the one side here, r squared plus 6,400, that's not going to change for now. We're going to leave it alone for now. Our other side, we do have to distribute, going back to algebra 1, multiplying through. Now, when we multiply through with this here, r times r would be r times 50 is plus 50r. R times 50 would be 50r. Then we would need to do 50 times r and 50 times 50. Well, 50 times r would be 50r, and 50 times 50 is going to be 2,500. Any questions on any of this here so far? Okay. We'll still have r squared plus 6,400. Before we do anything else, we do need to combine our like terms. Well, 50r plus 50r is 100r plus 2,500. Now, whenever we're dealing with this here, we want to try to get the variables on the same side, especially if we have a second degree. So we have r squared on both sides, yes? And when we deal with higher degree polynomial functions, or exponents 2 or greater, we want to try to get them all on the same side. So what I can do is I can subtract r squared from both sides as I'm moving it over. Because thankfully on the left-hand side, r squared minus r squared is 0, yes? So I have 6,400 is equal to, well, wait a minute. R squared minus r squared is what? So luckily for us here, the r squareds simplified out. Scroll back up a little bit. So then we subtract 2,500 from both sides because, again, since we just have r, we want to get it by itself, and it is. We want to get all the numbers on the other side. And this here would be 3,900 would be r. Then we divide both sides by 100. And we get that the value of r is 39. Any questions on this here? Was this as bad as y'all thought it was going to be? No. I mean, there's more steps to it, and there's a little bit more involved with it. But on a whole, the level of difficulty that you thought that this problem might contain was not anywhere near what you thought it ended up being. Are there any other questions on anything we've done so far today? All right.